In today's video, we're going to talk about some of the more popular, more prevalent physical network topologies being used in modern networks today. So we're going to kick off our conversation talking about the star topology. And the reason we're going to talk about this one first is because it's arguably one of the most popular physical topologies being used today, both in large and small networks across the world. So what is it and how is it designed? Well, we call it a star because everything is centrally connected. And I only have 4 devices on here, but if I put a fifth, and I aligned them like a star and I drew lines out, it would look like a star. So everything is connected to a central device, and that central device is either a switch or a hub. And so, for example, we have a switch here, and we have 4 different devices connected to it. We have a system here, one here, and one here. And they all have a separate network cable that goes directly into this switch or this hub. And the way that it's designed here is that it has built-in fault tolerance. So what do I mean by built-in fault tolerance? Well, what I mean by that is that if any one of these end devices go down, or if the network cable on any one of these end devices ends up having issues, then what happens is that it does not affect the rest of the network. And I know we haven't talked about how switches and hubs work yet, but we'll get into it. But I mean, if you think about it, let's say that this device crashed. Well, it's not going to affect how these 3 devices over here connect to the network. Now, let's say that one crashed and then somebody accidentally spliced the cable right here on this one. Again, it's not going to affect any of the other devices because they have their own cable that goes into the switch or the hub, which then connects to the network somewhere else. And so that's what we're talking about, fault tolerance. But there is one major downside. And that major downside is that we have one central point of failure. And what that is that's our switch or our hub right in the center. So what happens if we have a failure here? If this goes down, then the internet connectivity or network connectivity to all these devices, it all goes down. So let me clear this and let me redo this so it looks a little bit easier. So let me get my pen tool out. So let's say that our switch is going to go down. Let's say that it just fails, the hardware fails. Well, if this fails, then there's no connectivity to the internet or network here. There's none here, there's none here, and there's none here. And so it is a central point of failure for the entire network. However, switches and hubs are very reliable, and I rarely have ever seen them fail. For the most part, they are going to last for a long time. But if they do fail, the upside is that they're very easy and very inexpensive to replace. So if you know that your switch fails, you don't have any power to it, you simply just go and unplug the cables, plug the new ones into the new switch, and plug it into the wall and you're up and running. So it's not hard to troubleshoot, even though it is a single point of failure. So that's the star topology. Now let's talk about the mesh topology. And the mesh topology is very interesting in the fact that it's designed to have a very high level of redundancy. And so when we need to have a high level of redundancy in place where we need to make sure that our data is safe and secure and highly available all the time, then people tend to implement a mesh type topology. And the one thing with the mesh topology is that you can have a full mesh or you can have a partial mesh. And here I have a full mesh. And what we're talking about when we say a full mesh, we're talking about every single device on here has a direct connection to all the other devices. So if any one of them has a failure, or if any one of the cables has a failure, there's always a link to get to the other device. And if we think about it, so I have 3 computers, I have 1, 2, and 3, and I have a switch down here. What you'll notice is that this system has a cable directly to this system, has a cable directly to this system, and has a cable directly to this system. And so do all of them. And this is considered a full mesh because they have a direct connection to every other device on the network. The downside to this is that this system here, every single system on here has to have 3 network cards, 1 to connect to each other device on here. And the switch has to have at least 3 ports, which is fine. But the expensive part is buying these multiple network interface cards to make sure that you have this fault tolerance and redundancy in place. So with that said, because we have to have so much hardware that we have to add onto our systems, this is a really expensive topology to implement. And you're typically not going to see it in a standard local area network, but you're going to more so see it in a wide area network where you need this fault tolerance put in place. Maybe you have a router and it has 2 ports just in case one of the lines goes down. It's always going to have a connection to the other network on the other side of the WAN. So let's go ahead and let's take a look at how this would actually work. So for example, let's go ahead and say that the switch died. So the switch dies, and you notice that all of a sudden this cable becomes useless because it connects through here. This cable becomes useless as well, and this cable becomes useless as well. However, these systems can still communicate amongst all 3 of themselves because they have other connections. So you still have a connection here, we have a connection here, so this guy can connect to both of them still. The same thing with this guy, he has a connection here and connection here. Again, check mark, he can connect as well. And then over here as well, we have a connection here and a connection here. So they can still connect. And that's a great thing about having a full mesh. Now, we didn't talk about a partial mesh, and let me go ahead and erase the screen so it's not going to be so garbled with information on there. So what's a partial mesh? Well, partial mesh is where some of the connections in here aren't going to have a connection with every single device. So for example, with a partial mesh, we could say, maybe on this system, in this system, we don't need to have all those connections. Maybe we don't need to have a direct one here. We don't have to have that level of redundancy and fault tolerance on these 2 systems. So we can take this out, and it'll save us some money. And maybe we say the same thing here because we have the switch. It's going to be reliable, so we don't need a full mesh between both of these. And we take this cable out here in the network cards. And so that would be a partial mesh where you determine where you don't need 100% redundancy and fault tolerance in place, and you're just going to take some of those out of there. Now, just leading to the final point again, I want to reiterate is that this is very expensive to install. So this is not something you're going to put in an everyday network because it's just going to be far too cost prohibitive. So that's the mesh topology. Let's go ahead and let's talk about our next topology. And that's the point-to-point topology. And this is really as simple as it gets. This gets back to our initial discussion where we talked about the most basic type of a network, 2 systems connected together by a cable. It's a one-to-one point-to-point connection from one device to another. And it can be any device. I have a computer to a computer, I have a router to a router, I have a switch to a switch. I could do a router to a switch, I could do a computer to a router, I could do a computer to a switch. It doesn't matter, it's just a one-to-one connection. And we typically don't see these in local area networks, we see them used in a wide area network instead. And it's usually in a point-to-point wide area network link, which is going to be something like this right here in the center. And I'll go ahead and circle it. So it's typically going to be in a point-to-point from one network to the other where it's going across a wide area network. And remember that routers sit on the edge of your network and they connect your network to another network. So that's why we have routers, and we're not talking about switches or computers. So when we do see it, we typically see it, for example, a really good example would be a university or a big corporation where they have a campus with multiple buildings. They need to connect those buildings, where those buildings have their own specific separate local area networks, but they need to connect those together via a wide area link. Well, they're going to have something like this in place most of the time. And so you'll see connections like that between buildings. And one important note with this is that it does not provide redundancy. So we just looked at the mesh design. The mesh design provides redundancy. This one, if the network cable fails between these 2 devices, they can't communicate, and it kills the connection. And so that's the one thing to understand about a point-to-point, is that if it's going to be difficult for you to replace your cables, if it's underground or if it's in a tunnel or if it's up in the ceiling, it might be more cost prohibitive for you to, not cost prohibitive, but it might be more efficient and more effective for you to implement 2 cables together and do a mesh instead of a point-to-point. However, on the flip side, if that's going to be cost prohibitive and it's easier for you to go ahead and replace the cable from time to time, or replace one of the routers, or replace one of the switches, then just go that route instead. So that's the point-to-point topology. Now let's talk about our last one. And this is really what we see in the networks. This is a hybrid topology. And so what's a hybrid topology? Well, this is pretty much what you're going to see in almost every network today. And it's a combination of a lot of the physical topologies combined. And so we're talking about implementing our mesh, our star topology, and our point-to-point topology, and other topologies all together into one. So, for example, I went ahead and just did a diagram over here, and this diagram includes a combination of a star topology, a mesh topology, a point-to-point topology, and they're all combined. And so let's go ahead and let's see if we can identify them. And we'll start with the star topology, and we'll use our arrow tools. So we'll make the star topologies green. So where is our star topology? Well, let me go ahead and put a box around here to identify star is going to be green. We'll get our arrow out. Well, here's our star topology right here. Remember where we have our switch in the center and everything spreads out off of it? Well, this is our star topology where it connects to these devices here and to the router and to this other device here. So that's our star topology. And I'll go ahead and I'll just circle this like so. So where's our point-to-point topology? Well, there's a point-to-point topology as well, and there's actually, you could potentially say two, but really there only is one, and I'll mark this cyan. So here's our point-to-point, and where is our point-to-point network topology? Well, if you look hard enough, it's really, it's right here, because it's a single point of failure between this part of the network and this part of the network. And so this is a point-to-point between both of these, even though this is still part of this star and this is still part of this star down here as well. But again, it's a point-to-point between both of these. Now let's talk about the mesh topology. And let me go ahead and pick a different color for the mesh. So we'll go ahead and use red for our mesh topology. Well, where's the mesh? Well, it should be easy to identify. And I'll go ahead and I'll use a box on this one as well. Here's our mesh. We have a full mesh here where everything is connected to each other device. This device is connected to here, it's connected there, it's connected to there, and so forth. Now we also have a partial mesh right here as well. So I'll go ahead and use an arrow to show you the partial mesh. So I'm going to go ahead and point right here. So if you notice the connections to our router here, we have a switch here, we have a switch here, and it can get out to the internet from here, and get out to the internet from here as well. And so we have a partial mesh setup. Now you'll notice that I don't have, arrows going both ways to make this a full mesh, but it's only a partial mesh. So if this cable dies, the network can still come back around and use this to get back out to the internet. And if this cable dies, again, it can loop up through here and get out to the internet through here and go right on out this way to the internet. So this is our hybrid where we have a star, a mesh, and a point-to-point combination of physical topologies combined together to create one small network. And that's what you're going to see, and you're going to see that there's overlap. There's not going to be always a specific point where you're going to say, well, this is the point-to-point, and this is the mesh, and this is a star. You'll notice that this is a point-to-point, but again, it's part of this star. This is a mesh, but this is also part of a star as well, and this is a full mesh, and this is a mesh as well. And so that's why we call it a hybrid. But that's going to go ahead and conclude our introduction to physical network topologies. And before we end this video, I'm just going to recap. Remember, we talked about the star topology, which is the most popular one. We then talked about the mesh topology, which is good for high redundancy and fault tolerance. And then we talked about our point-to-point design, which we typically see in wide area networks. If you have any questions about this, please let me know. If it's still a bit confusing, I recommend going back through the video and watching it again, because it may not click the first time, and that's completely understandable. But if you do have questions after that, just go ahead and reach out to me and post a question on the discussion board, and I'll be happy to answer. And thanks for watching, and we'll see you at the next video.